All right, so I wanted to document this because I guess if you're not an electrical engineer, it's kind of hard to understand the impact of noise and how subtle some of the things are. But I've been working on my limit switches here and been having some issues. So first of all, let me explain what these are. So they're Toshiba 3.3 volt Hall effect sensors, and they have an internal pull up, which is nice because it simplifies, the wiring and some other things. Um, they, they shouldn't have any bouncing. Like a mechanical switch, literally physically vibrates and creates skips in the signals, and you have to debounce that, otherwise bad things happen. This thing is a digital signal, and it shouldn't have any bouncing in it at all. So anyway, so I'm going to run the homing routine, and then I'm going to move a wire, physically move one wire, not disconnect anything, and then I'll do it again. And if I'm right about what's been happening, you'll see where the noise comes from. So here we go. I'm going to go ahead and run the homing routine. The Z is first. So there we go. Works great. Then we get the x-axis, which you can only really see under here. Then we get the the Y. So that's homed. Perfect. No problem, no alarms. Okay, so now this is off. I'll just leave that the way it is, although I should try to put it back. Alright, I think it was something like this, but who knows? It probably will work fine now when I do another test. So I'll go ahead and run home. That looks okay. Alright, everything homed perfectly. Alright, so next thing I'll do is move these wires back about to where they were. Watch, nothing will go wrong. There we go. That's the behavior I was seeing. So let me show you that again. Down here, because this is where the sensor is. So it's supposed to home X. Actually, it's supposed to home X negative, and everything else is positive. Z is positive, Y is positive. So what I'll do here is I'll run $H X, which tells only the x-axis to home, and what you'll see is it moves positive twice. Now what's happening there is it somehow sees the limit switch is triggered, and so it's trying to back off of the trigger limit switch. It does that twice. And the same thing should happen for Z. This one, Z is actually working now. And this is what's so weird about this troubleshooting list is that, literally moving these wires back over here, and it might or it might not home. We'll try X again. Here we go. So that looks not right. So that was a fake home. Maybe it was right. The thing, I gotta look for the little blue light to go on here. Try it again. There, this is actually right. There it is, blue light. I don't know if that second one actually triggered, but this position is where I want it to be. So, I'm not really sure what the right thing to do is. This board I made has these terminal blocks, and there's no RC filters or anything on these limit pins. I put these chokes on just to try to troubleshoot it a little bit. I think that even though this is off, I think this wire is the culprit. Which is, if you don't know what you're doing, which generally I don't know what I'm doing, that can make it extremely hard to troubleshoot. So what I'm going to do is I'm going to put a choke on this wire, and then I'm going to put another choke down here. Okay, so I've got a choke on there. I've got a choke here for the spindle motor. I've got chokes on each individual limit switch. Then I've actually got some chokes on the wires coming out of the 48 volt power supply. So for the first test, I'll go ahead and see if it'll home. That looked okay. Alright, I'll try to home every axis. See, there you go. Z did not home. So, again, back here, move these wires just 10 inches. And I'll try it again. Let's see what happens. That is not right. Well, another thing I noticed is I have a cable here that came with these closed loop steppers. This cable here, I noticed when I switched the Z and the X, when this cable was attached to the X, my X problem went away, my Z became a problem. So these are shielded. I think I need to maybe tie all the shield wires back to ground. So that might be the next thing to try. I mean, all the cables are shielded. The funny thing is that these cables are actually shielded and tied to ground now. These are floating, which is maybe the next thing to troubleshoot. Anyway, so I move those wires aside from the pulse. We'll go ahead and try it again. There it is. Now that's the right behavior. Now, the funny thing is X does not look right. So let me try to home X. That is definitely not right. When I did my first CNC mill, I spent a lot of time trying to figure out how to get the thing not to have any issues. And this is my third one, and I'm still struggling. I'm gonna tie all those shields to ground, and we'll see if that works. All right, so I've taken the shielding from the cables that come out of here, not these intermediate cables, but just these guys. These aviation jacks, I don't really know how you're supposed to ground them, because on the other side there's no lug or anything for it. And I hate this because it's just so ugly, and it makes it impossible to connect or disconnect anything. But anyway, I've got all these going into my ground block. These I've tied in just right here. Again, I'm going to need to heat shrink all this, and it's going to make it impossible to do anything in this cabinet. But anyway, so I've got that there, and I'll go ahead and run a test home. Now these run on 3.3 volts. Now that is not right. That works. But this X is at completely the wrong side. And because the motor's right here, I have a sneaking suspicion that the motor, I don't know if it's the magnets in the motor. Well, now it's working. That's so weird. Well, no, it didn't. Huh. It only did part of it. Yeah, that's what I think about that. Alright, try it again. Home X. So it's not the sensor, because the sensor, you'd see a little blue flash. You see how it slow seek. You're gonna do it again. All right, so here is one of these signal cables for the steppers. So I'm gonna move that real quick. So now that cable is no proximity to this cable. And the only thing close to this cable is the USB cable. That shouldn't be creating noise. It could be, but I'm on battery, so that seems unlikely. Nope. I don't want to do it. I'll tell you what though, it is no fun to troubleshoot this. You know, it could even be these lights. It just could be a high frequency noise like anywhere. Okay, so here's another Hall sensor. I have a magnet here. When I trigger it, you see the light goes on. If we look up at the scope, we can see the triggering. And there should be no bounce whatsoever. So if I look the triggering, no bouncing. So that's a really nice clean drop from 3.3 volts down to 0. So what I'll do here is I'll take the scope over to the machine and set it up there and see what's actually happening on the machine. All right, this is the signal of the limit switch. Let's see if I can trigger it. Looks good, right? And then turn on my power supply. That's not so great. It's surprising anything works. So I'm terrible with the scope. Let's see, this is US. So we'll get out to microseconds. Yikes. So for a computer, 10 ms is a lot of time. Now, interestingly, I can disconnect it and see what it does. There's no pull-ups. This is what I'm getting on the scope without any without the sensor connected. And a division is 1 volt. So yeah, that's not good. That's really not good. All right, let's turn the power supply off. Look at that, it's like magic. Okay. Now, I don't know why the y-axis works. So I'm going to stop the video and connect the probe up to the y-axis and see why it looks so different, or why it operates so different. Yeah, well, I wish I knew how to use this thing. Seems like a really good tool. I don't know what that is at all. Maybe it's this. It might have something to do with the power supply. So what do I do about that? Well, I'm going to do some research. All right, so I've been doing some more troubleshooting. I changed out the power supply. This is a Meanwhile power supply, and I did a test where I literally disconnected everything that's connected to the motor drivers, and I still had significant noise. So what was the next thing that I did? I messed around with moving this further away, moving the wires around. None of that helped. And I did a couple other things. Anyway, what I have here is just a RC filter. So this is a 100 nanofarad capacitor and a 500 ohm resistor. And I think this is what's going to be required to get the thing to work. So up here, you can still see a ton of noise, but this is the capture of the homing sequence. So it's barely clean enough. The problem I have is, here, I'll put this thing in the run mode. So there's the noise. If I pull out this resistor, it'll essentially isolate the Hall sensor, and you can see that even with nothing connected to that GPIO pin on the ESP32, I still have a ridiculous amount of noise. So two things that I could do. One, I can just make a little breakout that has the RC filter on it. That's one thing I can do. The second thing I can do is put a level shifter in here between all of my step and dir signals and the motor driver. Now again, even with nothing connected between these two, I still have a ton of noise when I turn the power supply on. So I'm a little hesitant to go through all the trouble to set up a couple level shifters, because I need to level shift 6 signals. I'm a little hesitant to do that because I don't know that that's actually going to reduce the noise enough. So I think the most expedient thing to do would be to just make a little breakout board for these RC filters, which I should have put on this board. But I thought, foolishly, the Hall sensor would be clean enough that I didn't need to do that. So I think that's what I'm going to do next. My big fear is what happens when I turn the spindle on. How bad is the noise going to get at that point? Because the current spindle that I have is a brushed motor, and those are notorious for generating just completely ridiculous amounts of noise. I have another spindle that's brushless that I potentially might use. So I'm not really sure how that's going to go. So anyway, the troubleshooting continues. At least I can, with this RC filter, at least the homing finishes. All right, so I have more troubleshooting fun. So I built the RC filter. Weirdly, the RC filter, just on the x-axis, everything else seemed to work fine with the Meanwhile power supply. So at this point, I've got all my stepper controllers out of this one box, and I've got my ESP32 in a metal box as much as I can get it in there, and this is with the power off. Oh, and I've run an extension cord to a different outlet, hopefully on a different breaker. So here we go. I'm going to turn this 48 volt power supply on, and voila. So that's a 1 volt division on a 3.3 volt circuit, and I even have an RC filter hooked up to it. So at this point, I'm kind of out of ideas. My trigger voltage, let's set it at, I think the logic level it needs to be is 800 millivolts. So I'll do a single here. So it's not triggering, which is something, but it's also not connected to the motors. So, oh, there, it just triggered. So, not connected to anything, and I have that much noise. So I think I'm gonna cover my head in tinfoil. Honestly, I don't know what to do about this. I think these need to go into a shielded box, because another test I can run, I'll do this real quick. Alright, let's hope those capacitors discharge or I'm going to get a spark. Alright. Okay, so let's put this thing on run again. Alright, so turn this on. So that's the power supply on, but the motor's disconnected. These motor drivers. And according to the diagram on these things, they are supposed to they're supposed to have an opto isolator on these circuits, but it doesn't matter because there's so much electrical noise that I can't. There's nothing I can do. I can't isolate it. So yeah, these things are very, very, very noisy. And I almost think I need to put them in a shielded box with shielded cables. And maybe some additional isolation. I don't know. Okay, more troubleshooting. I have literally resorted to tinfoil. Hopefully nothing spark. Contact. Nope. Still there. It's it's in a box that's covered in aluminum foil. What the F? I mean, I have these little lengths that aren't shielded. That's better. I don't know. Maybe I need to run more wires to more stuff. So here it is with a single stepper driver enabled. And I can't put the, well, maybe I can. Yeah, I'll do this. So I have a ferrite bead already on the positive that's feeding the stepper. Again, these aren't even connected to each other. Let me make sure. All right. So I believe if I put one bead on, I think black and red are a pair, so I'll do black. No change on the scope. And then I think blue, black and red, blue and yellow I think are the other pair. I can't really remember. Try that here. No, don't change. Okay, try the yellow one. No change. Well, that didn't do anything. It's also putting the shielding. Oh, that seems to. No. When I touch the shielding, the noise goes down a little bit. I don't know what that means. Let me try the front of the motor. A little bit something. There's no bare metal in this. So what is that? Nope. So I tried popping one on here. It doesn't look like any difference. I'm going to try to disconnect this one and connect a different one and see if there's any difference. All right, so so I literally, the USB is not even connected. It's in a metal encasement here, and I still get this. I just it's so shockingly perplexing. I'm gonna just, maybe my probe is not behaving. Okay, so I've got it hooked back up to the this is the reference, I think. I don't really know how these things work, to be honest. I'll go ahead and turn it off and see if those little squiggles go away. Not completely. Yeah, at this point, I think it's a combination of the power supply and the noisy stepper modules, because I can't run a CNC machine with this. Oh, I'll try to think of something else next. Okay, so this is kind of interesting. I still got some funk, but I only have this bottom stepper driver powered right now. So I'm gonna plug the other one in. Okay, here's just the Z stepper. It's still got noise in it. Alright, that one looks clean. So what happened? You got all three plugged in again. It actually looks quite a bit better. I don't know what happened. Alright, I'm going to energize the Arduino. That was unplugged. Everything unplugged. So this is the ESP32 on. That looks better. Huh. I wonder what changed. Well, I guess I'll try to hook it back up and see what happens. Alright, well, I clearly have no idea what I'm doing. So I moved everything into what I believe is a Faraday cage, aka metal box. Just throw it, it doesn't do any good. I've got my signal wires for the quadrature encoders. That one's, yeah, they're all shielded-ish, I guess. Got them all tied together. I got the power cables all tied into here, which is the star, the superstar ground. And I have an ESP32 over here. That's not connected to any of that other stuff. I have some wires in some proximity. And then if I turn the power supply off, look at that. So I don't know what to do. I ordered another power supply. I've exhausted everything I could think of. Um, I mean, I can make a little board to do the RC circuit. I can make a board to do the level shifting for the step and dur, but I mean, with all that noise, none of that'll matter because it's not even connected. There's nothing physically connecting the stepper drivers or the power supply. They're on different circuits, I believe. I've tried 3 different plugs. I don't know, maybe everything in this place is on the same circuit. But this is really not fun. All right, well, I might have found it. So I was just poking around with the probe. Completely at a loss as to what to do. Disconnected everything I could. 1,000% frustration. I came over here and touched the probe, and you can see there's something in there, something happening. But what I was seeing was actually big trapezoidal waves, pseudo square waves. And what that led me to believe is that there's signal coming through the motor, and I guess it's making all the metal parts that are in contact with the motor, which is essentially everything is metal on metal. I suppose it's creating some voltage and noise. And so what I did is I just took a piece of wire up here to this screw, which is attached to this piece, and then I put that into here where I'm dangerously grounding my motor power wires, and amazingly the noise kind of went away. So I guess what I need to do now is I disconnected all the limit switches. That didn't do it. So I'm going to reconnect all of them, and then I have to redo these wires. I guess I'll use some shielded wires and run them over there for step and dur on the stepper motors. Again, just as a quick review, the motors worked fine. Everything worked fine. And step and dur, no problem. As soon as I turned on the limit switch monitoring, as an input, everything was an output. And as soon as the ESP32 tried to do any input, that's when all the noise became a monstrous problem. So, I'm going to go ahead and reconnect the limit switches, and I guess try to figure out the right way to wire these up so that at this point I want to keep this. I probably don't even need to do it anymore now that I connected this, but anyway, I want to keep them physically isolated. And again, I only know enough to be dangerous. It seems to me that the longer I make the wires, the more likely I am to pick up noise, because long wires, they act like antennas. And so maybe I don't know. I don't know what the right thing to do is, but this is not fun. Here is the RC board that I made. I've just got a 100 nanofarad SMD capacitor and a 500 ohm resistor, and then I tie everything in with these spring terminal clips. So this did work. I tried to use these little logic shifters. Unbeknownst to me, these are not capable of enough current to actually work. So I wired up 2 of these, and what I saw was that the ESP32 couldn't actually boot unless I disconnected one of them. And the reason for that is that it just couldn't source enough current, which means there was a voltage sag on GPIO 12, which is needed to set the flash voltage reading for the boot sequence on the ESP32. So I cut those out. I've got my little board here with my little crappy label, and I can't really move anything because it's a wiring nightmare of epic proportions. But I have this in a Pokemon box to provide some level of shielding. And again, I've got my RC filter hooked up. And then I use twisted pair to run this over to the board, which is in a metal box here somewhat. And I got my new power supply hooked up, which is a 48 volt Meanwell supply, which is it's a smaller supply. I'm a little worried it doesn't have enough current for my peak motor performance. But at the end of the day, I'm able right now to do the homing, and it works. But I still don't feel like I've gotten the noise to the point where I can have a high level of confidence that this thing will get back into the same position every time. And the whole point of homing on a CNC machine is that if you're in the middle of a job and you need to, and something goes wrong, let's say your bit breaks, or the controller has a problem and reboots, or any problem that you might have, you want to be able to home, and then you'll get back to your work coordinates that you set, assuming nothing moved in your vise or anything like that. So you want to have this repeat. Repeatability is the most important aspect of having the homing work. To net it out, I mean, I really think that the most important things I did here are each wire in the twisted pair has a ground. So you've got the signal wire with a ground wire twisted around it, and that should eliminate some of the noise. I actually ran out of shielded cable, so I just went with some twisted pair Ethernet cables. And I'm at a point where it works, and I wish there was a magic bullet that I could share that would help you understand exactly what you need to do to get as much noise reduced as possible. But there's so many things that can go wrong, like grounding the chassis, grounding all your shielded pairs, the signal between the steppers and the stepper drivers, the signal between the limit switches and the controller, where your AC power wires are, where your power supply is located. All of these things potentially can contribute to noise, and there's really no magic bullet. You kind of have to go through and simplify, reduce the number of things that you're looking at so that you can try to isolate the most important area that's creating noise. And the big problem here is that there could be multiple things contributing to the noise, right? So you might isolate one thing, but it might not do enough to actually get you to the point where you have a clean signal and you can get the homing repeatability that you need. So anyway, that's the nightmare that I went through to try to get this thing homing. Now I'm going to be focusing on finalizing the motor mounts. I've got some HTD 3mm pitch belts that I need to get installed. The super janky motor mount needs to be reworked, and I think what I'm going to do here is I might use aluminum extrusions. I want to be able to use different motors, and I want to be able to slide the motor mount back and forth this way. So I think I'm going to use a aluminum extrusion here, and I can create my return up that way, kind of an L bracket if I need to. But it'll be bolted directly down to here, and then I can adjust the motor tension, and then I can have different motor mounts, right? So for milling steel, this 3-to-1 reduction will give me a lot of torque. And so you want a slower RPM for steel, and you want high torque for steel. If I'm doing aluminum, I want high RPM, or let's say I'm doing Delrin, I want to have a higher RPM, and I don't need as much torque at all. So what I'd like to be able to do is to be able to swap this out easily, and or change the pulley ratios, which will impact the amount of torque that I can deliver, or the spindle speed that I can deliver. I've also ordered another NSK spindle that's got a 50 millimeter diameter and an automatic tool changer on it. I have one actually hooked up over here, and this is the smaller version. This is the 40 millimeter version. I use this for milling PCBs, and this thing is amazing. And having the ATC here, I have a bodged up switch that I hooked up here to a solenoid. And I just hit the switch, I can change the tool, put it back in and hit the switch and then probe for 0. And I'm on to the next operation. So this works really, really well. On this machine, I think for aluminum, the high-speed spindle is going to work really well. I think it's going to work really well for plastic and other materials. I'm not sure how well it's going to work for steel, but with a small tool like this, it might actually work pretty good for steel, depending on what I'm trying to do. So I want to be able to swap in that high-speed spindle and then swap this low-speed spindle back in, because this thing allows me to have, this is an ER11 collet, but I can also put something like this in, which is an ER32 collet, and it gives me a lot more options as far as the tooling that I can use with the machine in general. The NSK spindle has, I think it's a maximum of maybe 8 millimeters, and the collets are like $100 a pop. Whereas, this ER12, I think was like $15 for this whole thing, and then you can buy a set of collets for, $40 or $50. They're not real high quality, but they're cheap, and the same goes for the ER32 setup. So. Anyway, that's what I'm going to do now that I have some level of homing ability, and assuming that I can get it to do some level of repeating, and I can prove that it, milling a few pieces, that it's going to work without the controller failing or rebooting or throwing alarms or any weird funkiness. Then I can actually figure out some more permanent wire management. I'm also going to be replacing these control wires. These are DB9 that go to the encoders on that give the feedback for the closed loop stepping. These are a little bit too short. These were 3 feet. I want to go with 5 feet so I can put this whole thing underneath and keep it away from any chips, any metal chips, which will, aren't really good for your power supply or your electronics because they'll short everything out. So I'm going to make some PCBs that I can plug in the other side of these cables, and that'll also make it easier for me to connect and disconnect the whole assembly, which right now is not easy to connect or disconnect. Anyway, thanks for watching.